Alright, so what I've got here is a worksheet that will basically allow you to work through some of the more basic aspects of topic 8. And what I'm going to do is just record a few videos to act as a bit of a guide for how you tackle these problems. Now firstly, you have several resources that you can use to help you with these problems. You've got the Oxford IB study guide, which looks like that, and you can look at chapter 8 to get a really brief summary of all of the things that are going to be in this topic. And you also have this Pearson Baccalaureate textbook, which gives slightly more in-depth explanations. And then you have the whole internet, which you need to use with a pinch of salt. And then we also have this data booklet, which has a few of the equations that you're going to need. Not much. In fact, it's only the top two here that we're going to be using for this worksheet. Okay, so the first topic that we're going to look at is energy degradation, power generation, and world energy resources. So I'm just going to go through this. I'm going to answer a couple of the questions just to give you some indication of how to do it, and just talk a little bit about the other ones. Alright, so the first question says, explain what is meant by degraded energy. This is a term that you should be able to just look up in those textbooks and define, and then explain it, maybe with an example. Construct an accurate Sankey diagram for a car engine. I put this in as the first example because it's actually an example that's done in this textbook, and you can just use the example to draw that diagram. Basically just copy the diagram to get the hang of how to draw them. And the second one is a simple example, a typical electric light bulb. So I'm going to do that one as an example. So let's say we have a 100-watt light bulb. So if we input 100 joules of energy, so I'm going to represent 100 joules by 2 centimeters, say. So if we input 100 joules of energy, 100 joules of electrical energy, and the useful energy that we want to get out of this is light. Then we can draw the useful energy along the top here. There's a range of variations of how you can draw these. So the useful energy is going to be this way, and the other energy is going to drop off the bottom of the diagram. So if you just look up online what the efficiency is of a typical 100-watt tungsten light bulb, it's about 3%. So that's going to be very hard for me to draw because it's going to be so small. So 2 of these is 10%. I should have drawn it much larger. 2 of those is 10%, so 3% is less than a millimeter on here. So let's just draw that as best we can. So there's our useful energy. So useful light energy out. Three joules, and the rest of the energy is lost as heat. And so what we can do then is just draw that like this. In fact, that should probably be in line there, so that should be up to about there. And the energy lost as heat heat energy lost will be 97 joules. So this is assuming efficiency of approx 3%. So there's a Sankey diagram that shows a very inefficient energy transfer, because the amount of useful energy out is only a tiny fraction of the amount of energy put in. And these Sankey diagrams are really good at immediately getting a glimpse of where energy is being lost. So that's how we draw a Sankey diagram. And there's another example for you to do here, which is a bicycle dynamo in which there are several instances of heat loss. Again, if you have a look at the examples of Sankey diagrams in the textbooks, it should become clear how you can do these more complicated ones as well. Question 3 says, explain what's meant by energy density. And this again is something that you could very easily just look up in either of the two textbooks. Draw an annotated graphical representation to illustrate the fuels we use to provide electrical energy. There are examples of these in the books, and you could draw, say, a pie graph or some representation of the proportions. Okay, here we have coal, oil, and natural gas. They're fossil fuels. And just referring back to your diagram, you should be able to explain what proportion of the world's energy is supplied through those. They're considered non-renewable. Why is that the case? Again, you should be able to identify the reasons for that. Define peak oil and explain why some consider this a serious and imminent problem. So this, again, you can give a very brief answer, and a quick Google search will tell you a little bit about what peak oil is. And it's one of the reasons why we're concerned about fossil fuels. Another reason that we're concerned about fossil fuels, of course, is that burning them causes the emission of a lot of greenhouse gases, but we'll talk more about that later. And here again you can refer to the Pearson textbook to have a look at some of the advantages and disadvantages, if you can't think of them yourself, of these various sources of energy, and try to identify the sort of key advantage and the key disadvantage, and there may be two in some cases. Okay. All right, and we'll work through this example.